Good morning, Namaskar and welcome to the course once again. In the last lecture, if you remember, we discussed few concepts related to risk analysis. We discussed how to draw investment risk profile. We discussed how to draw AID, which is acceptable investment diagram. We also learnt few concepts related to auxiliary investment criteria or rather auxiliary decision criterias. Under that, we discussed the criteria pertaining to minimization of variance, probable future criterion and aspiration level. In this lecture, we are going to learn one very important aspect under risk analysis, that is to consider the risk in aggregated cash flow. So, when I say aggregated cash flow, if you remember, we have been drawing cash flow diagrams something like this. Now, this is what we are saying aggregated cash flow, because here at time t is equal to 0 you are having some cash flow, at time t is equal to 1 some cash flow, likewise at different points of time we are having different cash flows. Now, so far what we have been doing was to assume that this x0, x1, x2 all are constant. Subsequently, if you remember, we said no, x1 can't be constant, they can vary. So, I started taking different values for these x1. Likewise, I took different values for this x2 and then I understood how to calculate the net present worth and thereafter how to take the decisions. Subsequently, in the last lecture, if you remember, for each of these cash flows, I also assigned certain probability values. For example, corresponding to this x1, let us say the values could be x10, x10 dash, let us say x10 double dash, and associated probability could be P1, could be P2, could be P3 and so on. And under this situation, we also found the net present value. We call that net present value as the expected value. You understand the concept of expected value from one of the previous lectures. It is nothing but the weighted average of different cash flows. And how do we get this? You multiply different cash flows with their probability values and thereby you get the expected value. We have also learnt how to calculate the variance and thereby the associated standard deviation. Now, the analysis what we are going to do right now is assuming that the cash flows are independent. When I say independent, it means the cash flow that has occurred in year 1 is in no way influencing the cash flow in year 2 and so on. It is not in any way connected to cash flow in year 3, let us say x3 and so on. So, we are assuming that x1 is independent of x2 and same is independent with x3 and so on. So, this is what we are going to learn. In higher classes, you will be doing the analysis in which you will assume that cash flow in 1 year is dependent on the cash flow in the next year and so on. But that is beyond the scope of this particular lecture. We are concentrating right now on the independent cash flow, that too for a single investment. So, for this example, let us assume we are investing x0 at time t is equal to 0 and it is giving me a return of x1, x2, x3 and xn at different time periods 1, 2, 3 and n respectively. So, I will quickly give you some of the formulas that we often use in the context of finding the risk in aggregated cash flows. So, as far as the present worth formula is concerned, it is nothing new to you. What you do is, it is simple, x0 you write it with proper sign and add x1 divided by 1 plus I plus x2 divided by 1 plus I raised to power 2 and so on. So, this is how you can derive and this is how it has been written here. So, present worth is equal to x0 plus x1 upon 1 plus I plus x2 upon 1 plus I raised to power 2 and so on. Now, the expected value of present worth, you have already been calculating this. I am just introducing the symbol mu 0 here at time t is equal to 0. that is the mean value there for all my x zeros. For year 1 it is given by mu 1 upon 1 plus I, mu 2 upon 1 plus I raised to power 2 for the second year, this is for the third year and this is for the nth year. Variance is given by this formula, which is sigma 0 square plus sigma 1 square upon 1 plus I raised to power 2 plus sigma 2 square upon 1 plus I raised to power 4 plus sigma 3 square upon 1 plus I raised to power 6 and finally sigma n square divided by 1 plus I raised to power 2n. Now, this also we can write it in terms of p given f factor. So, for this expression 1 upon 1 plus I raised to power 2, I can as well write p given f for an interest rate of I for 2 years. This will be converted like p given f for an interest rate of I and for a time period 4. This one you can convert it like this, p given f for an interest rate I for a time period 6, and finally this one you can convert it in terms of p given f for an interest rate I and for time period 2n. So, using the concept of these formulas, we will try to evaluate the risk, and as you know, risk we are measuring in terms of variances and standard deviation. So, let us move to one small question in which we are given that there is an investment proposal in which you are investing 2000 rupees at time t is equal to 0, and this is likely to give me a return of 1000 rupees at the end of year 1 with standard deviation of 200. So, that means the distribution at the year 1 is something like this. Mean value of return is 1000 and its standard deviation is 200. In some of the previous problems, if you remember, you were not directly given the mu value and the sigma value. In this problem, in order to simplify and to save time, I have directly given you the expected value, which is mu, and the standard deviation for each year's cash flow. So, here also this is 1000, this is 200, and here also this is 1000 and 200. So, now you must be wondering how from a simple assumption we have come to a very complicated situation. Now, what is happening here? Earlier in all our cases we were assuming that this mu is fixed, there is no standard deviation, that was a constant value of cash flow that we assumed, that was certain to be occurring. Now, subsequently we started changing it. So, we said that 1000 could become 1100, it could become 900, anything, but we did not assign any probability. In subsequent lectures, what we did, for each of these state of occurrences, whether it is 900, whether it is 1000, whether it is 1100, we started assigning probabilities. So, we said okay, corresponding to 900 probability is 0.2, corresponding to 1000 probability is 0.3, and corresponding to 1100 let us say probability is 0.5. Now, from there we were able to calculate the expected value. For example, if I give you for year 1, let us say the probable values are 900, 1000 and 1100, you can easily find out its expected value if you know the probability. Suppose this probability is 0.2 here, this probability is 0.3 here and this probability is 0.5, you can easily calculate the mu value from here. So, mu will be given by 900 into 0.2 plus 1000 into 0.3 plus 1100 into 0.5. Suppose this is coming to be some value x. Now, knowing this x, we can very easily calculate the sigma square and thereby sigma. So, how do we calculate sigma square for this? It would be 900 minus the mean value square of this multiplied by 0.2 plus 1000 minus x square of this multiplied by 0.3 plus 1100 minus x square of this multiplied by 0.5. Now, you take the under root of this and you get sigma. So, to avoid all these calculation in the problem, I have directly given you these two values. So, what is the expected value at the end of year 1? What is the probable standard deviation for year 1, all these values are given to you, not only for year 1, but for year 2, year 3 as well. Now, for finding the risk out of this proposal, what we need to do is, we need to find the net present worth for this option. And you remember, I had given you this formula to calculate the net present worth. It is something like this. So, expected value of present worth is given by mu naught plus mu 1 upon 1 plus I. So, in this case mu 1 is one single value, which is coming to be 2000. So, you can write minus 2000 here, plus 1000, which is the mean value here, divided by, let us assume I is equal to 10%. So, I write 1 plus 0.1 for year 1, this becomes 1000 by 1.1 raised to power 2 for year 2, and plus 1000 divided by 1.1 raised to power 3. So, this is the expected value of net present worth. You can write expected value of net present worth using the formula that we derived earlier, and this value is going to be 487. This is coming to be 487. So, this calculation has been performed here. You can see here minus 2000 plus 1000 divided by 1 plus 0.1. This 0.1 is nothing but your interest rate. Here for second year, 1000 divided by 1 plus 0.1 raised to power 2, and here this is 1000 divided by 1 plus 0.1 raised to power 3. So, you are getting 487. Now, remember, this is expected value. In earlier case, we were assuming that it is going to be certain. So, there was no probability associated with anything, that was bound to happen. But now, here we say that this is expected value. When you say expected value, you know that it is only a mean value. That means, there is every possibility that the expected value could be either more than 487 or less than 487. So, there is a 50% chance that the expected value of net present worth is likely to be less than 487, and there is again 50% chance that expected value is going to be more than 487. So, you can draw a normal distribution like this also, and here is your mean 487. So, there is a possibility that expected value can be below 487, and there is possibility that expected value can be more than 487 also. Now, we also need to calculate the variance and thereby the standard deviation. So, if you go back to the variance formula, it is sigma 0 square plus sigma 1 square upon 1 plus I raised to power 2 plus sigma 2 raised to power 2 upon 1 plus I raised to power 4 sigma 3 square upon 1 plus I raised to power 6, because my duration is only up to 3 years. Now, you will find that sigma naught square is 0. Why? Because this 2000 is a fixed value, it is not going to change. So, if there is no variation in any amount, the variance is going to be 0. This is a constant. So, the variance associated with that is going to be 0, but it is not the case with other values at different points of time. There, if you remember, the variance for year 1 was given to be 200. So, this is 200 square upon 1 plus 0.1 raised to power 2, 200 square upon 1 plus 0.1 raised to power 4, and finally 200 square upon 1.1 raised to power 6, and this is coming to be 82,958. If you take the root of this, so sigma will become under root 82,958, and if you calculate, this is coming to be 288. So, what you find here is that mu is 487 for overall expected value of net present worth, and the standard deviation associated with that is coming out to be 288. So, that means, as you know, when you draw this, standard deviation is 288 here. That means, there is a likelihood that the value of net present worth might go below 0 also. Now, that is what is the risk associated with this particular proposal. I want to find what is the probability that my net present worth becomes less than 0. In those cases, I am going to make losses, because as long as my net present worth is more than 0, there is no issue. But here we got that sigma value as 288 and mean value is only 487. So, there is every possibility that my net present worth may fall below 0. So, that is what I am interested in finding, and that is what I am defining it as risk. So, what is the risk of making losses? When I say I am interested in finding the value of probability in which the net present worth is going to be below 0. So, you know the concept of standard variate or normal variate, we define it as Z. So, Z is given as x minus mu upon sigma. X is the desired value, mu is the mean value, which is 487 in this case, and sigma is 288. Now, I am interested in finding the probability corresponding to a net present worth of 0. So, x I keep it as 0. So, my Z becomes 0 minus 487 divided by 288. If you calculate this, you will find it is coming very close to 1.7, it is about 1.69. Now, all of you are familiar with normal distribution table. The table is very much like this. There are two types of table rather. In this table, if you look these values carefully, the values are given from minus infinity onwards. So, that is why if you find the value of Z is equal to 0, it is coming to be 0.5. Z is equal to 0 would be somewhere here, right, and corresponding to this, the value given in this particular table is coming to be 0.5. It means this table is measuring the value from minus infinity onwards. Now, we have to locate a point. You will find this is coming to be minus 1.69. You also know that the normal distribution graph is symmetrical. So, I can as well find the value corresponding to Z is equal to 1.69. So, I will see where this 1.69 comes. So, 1.6 is here and I go on moving here and I am in the last column and I find this is the value. So, corresponding to Z is equal to 1.69. So, it would be somewhere here. 1.69 is somewhere here. So, 1.69 will be minus 1.69 would be somewhere here. So, corresponding to 1.69 my probability is 0.9545, right. Now, I will draw the figure once again. Now that I have got corresponding to 1.69 my value is corresponding to Z is equal to 1.69, my probability is 0.95. How much was it? 9545. So, corresponding to this, it is this whole value is coming to be 0.9545. That means the area under this curve up to here, all these areas are equal to 0.9545. But remember, I am interested in minus 1.69. So, it is symmetrical. So, it would be somewhere here. So, I am interested in this area because less than 0 area is represented by this. I want what is the probability of net present worth going below 0. So, if this whole area is 0.9545, this area is going to be how much? It is going to be 1 minus 0.9545, which is roughly about 4.6%. So, this area is also 4.6%. So, what you find? The probability of making losses in this investment proposal is 4.6%. So, let us say it is very close to 5. So, that means 5 out of 100, if you invest in such proposals, you are likely to make losses. Now, we would not have understood the losses had we not carried out the risk analysis as we have done now. Because if you remember in earlier cases, we were not at all bothered to even look beyond the net present worth if we were getting a net present worth in positive. Here also we would not have looked beyond, but just because we noticed that sigma associated with this project is very high. It was coming to be 288. So, even though my net present worth's mean value is 487, I am still likely to go for losses. Of course, not very big losses, but still there are chances. Now, this we would not have known had we not carried out the risk analysis. So, this is the power of carrying out risk analysis, and you know that knowing this, now I can take a very wise decision whether to go for this alternative or not. So, risk analysis in a sense is helping us go into more detail and to analyze whether this particular option is worth pursuing or not. So, this is one very good application of risk analysis we have discussed in the context of aggregated cash flows. Now, connected to this, we take one another example in which, let us say, we have to decide for some kind of a maintenance policy. So, what happens in civil engineering projects, if you look, there are large number of equipments. There would be equipment for excavation, there would be equipment for concreting, there would be equipment for washing, a large number of equipment. Now, you also have a setup to have repair work done, to have maintenance work done for all these equipment. In fact, you will have a separate department itself, we call it as plant and machinery department. Now, one of the decisions that they have to take is whether to go in for preventive maintenance or whether to go in for breakdown maintenance. Now, you have to understand these two terms very carefully. What happens in breakdown maintenance? You are not at all bothered about going for preventive maintenance. So, as and when the machine breaks down, you go and repair it. Obviously, it requires more money compared to the preventive maintenance. In preventive maintenance, you have a schedule for each of these equipment. Okay, this is a tower crane, this is a mobile crane, this is a batching plant. This will go for maintenance on 1st of every month. This will go for maintenance on 10th of every month. So, you have a quite a big schedule for each of these equipment already made, and your plant and machinery in charge will be sticking to those schedule. Now, what is done is, let us say we are having a situation in which we have to make a choice between whether to go for a preventive maintenance or whether to go for a breakdown maintenance. So, there is a particular organization which has collected this data in the form of this particular table. Now, that organization has got 30 similar machines and that exhibit the probability distribution of failures as shown in the following table. It is also noticed that the cost of remedial action after a breakdown is averaging $100. That means, suppose some equipment has failed, it is under breakdown, and if you want to repair it, on an average it is costing you $100. And if you are doing the preventive maintenance, the cost is very low, it is only $30 per machine. Now, the organization has collected this data, and based on that data what they are saying is, there is a probability of failure of 0.2, that the equipment will go under breakdown 1 month after the maintenance. Likewise, 2 months after the maintenance, the probability of failure is 0.1, 3 months after maintenance, the probability of failure is 0.1, 4 months after the maintenance, probability is 0.2, 5 months after maintenance, the probability is 0.4. These data have been captured based on past experiences. Now, as I have been telling you repeatedly, solving a problem is not a big deal. The formulation of problem requires your time and effort, and it comes to you only with experience. So, although this data has been captured very crisply in a very small table, but believe me, collecting such data takes a lot of time and effort. Now, in this particular problem, we have to make a choice whether to go for preventive maintenance or whether to go for breakdown maintenance. Suppose I go for breakdown maintenance, then what is the frequency on an average of the breakdown for these equipment? So, that I can calculate again based on the concept of expected value. So, you can find 1 month after maintenance, probability is 0.2, So 1 into 0.2, 2 months after maintenance probability is 0.1, so 2 into 0.1. 3 months after this probability is 0.1, so 3 into 0.1. Likewise 4 into 0.2 and this is 5 into 0.4. So if you go and calculate it like this, you will find you are getting this value as 3.5 months. So that means 3.5 months is basically the frequency in which machines are breaking down. So let us say you have 30 machines and you are incurring $100 as breakdown maintenance cost. So this will get distributed over a period of 3.5 months. So this is the cost that you have to incur in case you are going in for breakdown maintenance. Now you have other strategies also available. For example, you can make a choice of having a preventive maintenance every month, or for that matter every 2 months or every 3 months, every 4 months, every 5 months. Now we would like to calculate how much is going to be my cost implication should I go in for adopting 1 month period of preventive maintenance. So how do I calculate it? So looking at this table, 1 month after maintenance probability of failure is 0.2. So 30 machines we are maintaining it at a cost of $30. So 900 is the fixed cost. This is what you have to pay in case you are going in for breakdown maintenance. Now even after this maintenance, what this table says, there is a 20% equipment which is going to fail. So that would require again breakdown maintenance. So 900 is your cost of going in for preventive maintenance. How? 30 machines at a rate of $30, so it is $900. Now out of this 30, you will find 20% will still go for breakdown, and for that how much additional cost is needed? It would be 30 multiplied by 0.2 multiplied by 100. So what is going to be your monthly cost? 900 plus 30 multiplied by 0.2 into 100. So this is going to be 1500. So that means if you are going in for monthly prevention maintenance, in that case your cost liability is coming to be 1500. Now in the same manner, let us assume I am going in for bi-monthly preventive maintenance. So how does cost come to? You will have to find it like this. This is what we did it for month 1. You can see $900. How it is coming? This is coming by multiplying 30 with 30, $100 per breakdown, 30 machines, and probability of failure 20%. So we are getting $1500 per month in case you are going in for preventive maintenance policy every month. So PM1 we are denoting it by. Now in case of PM2 policy, let us say, that means every 2 months you have decided to maintain the equipment using preventive maintenance policy. So in that case the cost will be calculated like this. First month, out of 30 equipment, 20% will go under breakdown. So you can see 30 into 0.2, it is 6. Next month again 30 into 0.1, if you go back to the table, it says first month probability is 0.2, second month probability is 0.1. So I calculate this as 30 into 0.1, which is 3. Now one thing you have to notice here is that these 6 equipment which you have maintained in this month, 20% of that again may turn out to be under breakdown. So you can see here it is 6 into 0.2. The probability again is 0.2 for failure in case you have maintained it, and it may fail even after 1 month. So this value is coming to be 1.2. So if you add how many times you have to pay for your breakdown maintenance, it is 6 plus 3, which is 9 plus 1.2. So 10.2 here, and the breakdown maintenance cost is $100. So this is 1020 here, and 30 into 30 anyway you know, because every 2 months you are maintaining 30 equipment at a cost of $30. So 900. So total cost is coming to be 900 plus 1020, it is 1920. So, this is the cost implication for 2 months. So, per month if we have to calculate, it is 1920 by 2, which is 960. So, if we were doing preventive maintenance on a monthly basis, we were incurring 1500. When we changed it to bi-monthly maintenance policy, we are getting a cost implication of 960. Now, in the same manner, you can do it by assuming that you are going to maintain your equipment every 3 months. We are calling this as PM3 policy. So, here also as before, this is 30 into 0.2, because whatever equipment you maintained, there is a 20% chance of failure. In second month, 10% chance of failure. In third month, 10% chance of failure. So, 6 plus 3 plus 3 is here. Now, out of this 6, again 20%. Out of this 6, again 10% at the end of 2 months. So, this is it. Then when it comes to this 3, here you have 3 into 0.2 from the previous table, and finally here is 1.2. Here also 20% may go under breakdown, so 0.24. So, if you add all this 6 plus 3 plus 3, which is 12, plus 1.2, 13.2, 13.9, and this is finally you are getting 900 here plus 1464, you are getting 2364, right, and this is for a period of 3 months. So, when you divide it for calculating the monthly cost, you are getting 788. Now, all these values whatever we have calculated, I can put it in a separate table. So, here you can see, if you look at the last column, if you are following a policy of preventive maintenance on a monthly basis, your cost is 1500, bi-monthly 960, 3 monthly 788, 4 months 789, 5 months 944. So, you find your least cost is coming when you are going in for a policy which involves preventive maintenance every 3 months period. Now, you have already seen the cost implication of breakdown policy. So, this is how you remember, you got it. So, the time period between breakdowns is nothing but the expected value, 1 into 0.2 plus 2 into 0.1 plus 3 into 0.1 plus 4 into 0.2 plus 5 into 0.4. So, it is 3.5 months. So, the cost is going to be distributed over 3.5 months like this, 30 machines, $100 per machine. This is the breakdown cost, and divided by 3.5 months. So, this is coming to be 857. So, if you are going in for breakdown maintenance, it is costing you 857. If you are going in for preventive maintenance monthly basis, 1500, bi-monthly basis we are getting 960 and then 788. So, this is 960 and 788. You find that this is coming to be the cheapest one. So, what is the conclusion? We can go in for the preventive maintenance policy every 3 months. So, these are some of the examples which we can think of in the context of civil engineering, wherein you can apply the concept of expected value, you can apply the concept of finding the risk, and so on. So, in this lecture I have given you an overview of finding the risk in aggregated cash flows. I have given you the formulas to calculate the expected value. I have given you the formulas to derive the variance and thereby the standard deviation. Using the concepts of these two terms and using the standard deviation, rather the normal distribution tables, you can easily find out the risk associated with any proposal. So, if you remember from the very beginning, we started with our assumption that cash flows are certain. Then we started changing them, and then we tried to find out what is the impact of these changes on my overall decision. Subsequently, we started assigning probability values also, and then I am in a position to find out the risk associated with all these investment proposals. Now, this would not have been possible if we would not have involved the concept of risk analysis. So, as before, I will just give you the reference books quickly. These chapters are covered in detail in my book on construction project management theory and practice, published by Pearson. There are other books also which are mentioned here. You can refer any one of them and try solving few similar examples to get more clarity. So, with this we stop this lecture and see you sometime in other lecture. Thank you very much.